First order system. So first order system is referred to the system that only involves one pole which is on the real axis. Generally, the transfer function of the first order system can be stated as here, where Gs equal to Cs over Rs, where C is referred to output, Rs referred to input, equal to K divided by tau S plus 1. K represent gain and tau represent time constant. So by taking into account Gs as a transfer function for an open loop system, so if the system input apply a unit step response Rs equal to 1 over S, then the output Ct of the system can be derived as follows. So where when we substitute this Rs in this equation, so the equation becomes Cs equal to 1 over S times K divided by tau over S plus 1 divided by tau. So by apply partial fraction, so this equation become Cs equal to 1 over S minus 1 divided by S plus 1 divided by tau. And then after we taking inverse Laplace for this equation, so this equation will change to equation in time domain, where the result become Ct equal to 1 minus exponential power of negative t over tau. So referring to these results, it can be seen clearly that there are two parts involved, which is we call transient response, this part, and steady state response, this part. So this part also known as a forced response. This part also known as a natural response. For example, if the transfer function of the open loop system is Gs equal to S plus 1 divided by S plus 4, so when a unit step input is applied, then the output response of the system can be obtained like this. So after we do partial fraction and apply inverse Laplace transform, so we'll get the Ct equal to 1 over 4 plus 3 over 4 exponential power of negative 40. Okay, this is the output for the system in time domain. So this 1 over 4 is referred to the forced response, and this component is referred to the natural response or transient response. Let us return to this equation. So based on derivation that we have done, so the input pole at the origin generate the forced response Cf of t equal to 1. And the system pole at negative 1 over tau here generate the natural response of system Cn of t equal to negative exponential power of negative t over tau. So when t is equal to tau, so when we substitute this into this equation, so this one become exponential power of negative 1 equal to 0.36. So the output response of the system become 1 minus 0.36, which is equal to 0.63. Okay, this 0.63 means 63% of the final value. That means the time constant of the system can be defined as the time required for the signal to attain 60% of the final value or steady state value. This figure shows the output response of the system of the first order system. Some information can be obtained through this response, that are rise time Tr, settling time Ts, and final value. Rise time is the time for the system output response to change from 10% to 90%, referring to the final value. While settling time is the time for the output response to reach steady state with the criteria of either 2% or 5%. It depends what criteria we choose. And the steady state response of final value can be obtained when t this one is replaced with infinity, which will cause the transient response to disappear. Before we go further, so what is time constant? So time constant is the time takes for a step response to rise to 60% of its final value. So thus, time constant can be considered as a transient response specification for a first order system, since it is related to the speed at which the system responds to be step input. Now let us look at what is rise time. So as I mentioned just now, rise time is defined as the time for waveform to go from 0.1 to 0.9 of final value, or 10% to 90% of final value. So rise time can be found by determining the value of time when output response CT is at level 10% and 90% of the final value. As we already know, the response for the for the first order system is CT equal to 1 minus exponential power of negative 80. So we can find this value of t by put the result for CT equal to 0.1 and CT equal to 0.9. So by doing so, we get the result of t for CT is equal to 0.9 is equal to 2.3 over A. And the result for the CT when CT is equal to 0. The result of T when CT is equal to 0.1, so the value of T is equal to 0.1 over A. So based on these two results, so we can obtain the formula for TR is equal to 2.3 over A minus 2.1 over A, which is equal to 2.2 over A. So this is the formula for how we can find the value of rise time. For settling time Ts, it can be defined as the time for the response to reach or stay within 2% or 5% of the final value. So this 2% and 5% is depends on which criteria that we choose. So if we choose criteria 2%, so that means it will stay within 2%. If we choose 5%, so the final value will stay within 5%. So the formula for settling time can be obtained by letting the output response of the first order system equal to 0.8 or 0.5 like this. This value is depend on which criteria that we choose. If we choose criteria 2%, so we just put 0.98 like this. If we choose if we choose 5% criteria, so this value become 0.95. So this is formula that come out from this derivation where Ts is equal to negative ln 1 minus 0.98 divided by A. So this equation becomes 3.91, where we can round out this to 4. So Ts is equal to 4 divided by A. So for 5%, for criteria 5%, so this is the formula that we get, where Ts is equal to 2.996 over A, or 3 divided by A. So as a conclusion, formula for Ts for criteria 2% is Ts equal to 4 divided by A, and for criteria 5%, Ts is equal to 3 divided by A. Let us look at this example. So the question is determine time constant tau settling time Ts, rise time Tr for a negative feedback system as shown in this figure. So to solve this problem, first we have to settle this plot diagram until we get Cs over Rs. So in this case, Gs is 1 over S plus 2. This system is system with unity feedback, means that Hs is equal to 1 here. So by using feedback formula, which is Cs over Rs equal to Gs over 1 plus GSHS, so the result for Cs over Rs become 1 over S plus 3. Okay, based on these results, we know that A is equal to 3. So to find the time constant, formula for time constant is 1 over A. So that time constant is 1 over 3. Okay, to find the Ts settling time, so we just use the formula that we have derived before, where the formula for Ts is 4 divided by A. So in this case, A is equal to 3. So Ts is equal to 4 over 3. And also same for the rise time, we just use the formula that we have derived before. So Tr is equal to 2.2 over